All right, today we're going to do the balloon model of a universe lab. Uh, we have our materials. We have a balloon. We have a metric ruler that has centimeters on it. And instead of the 4 stickers, what we're going to do is I'm going to represent the stickers with letters. All right, I'll use probably a green marker since it'll probably show it better on here. And we'll see how that turns out. The purpose of this lab: how does the model, or this model, and known facts about the universe help us predict the future of the universe? So what I want you to do is, as we go through this, is kind of think about how could this balloon, how could those stickers, or in this case, the letters that I write on the balloons, how could they represent the Earth itself? And not just the Earth, our whole universe. How does it represent the planets, the stars, and all of that stuff? Our procedure: I'm going to blow a little bit of air into the balloon as it tells me to do until it becomes a round shape. I'm going to hold the end to keep the air from escaping. In the past, when students blew up the balloon, they would actually tie it and end up having to untie it because nowhere on here does it say to tie the balloon. It just says to blow it up and hold it. All right, so in science, very important when you're doing your labs to make sure that you read the directions carefully, sometimes 2 or 3 times, just to make sure that you have it down. So I'm going to blow the flat balloon that we have here. I'm going to blow it up to make it round so that I can write on it. Alright, this here should be good enough. Hopefully you can see the balloon. I'll zoom out a little bit to make sure that you get a good shot of it. That's the balloon. Now we're going to put the markings on it in a few minutes. It says add the 4 stickers using the diagram for location. So on my paper here, I'm going to mark my own little diagram. A, B, C, D is what I'll label it. A, B, C, and D. And I have to be careful that whatever I put on this paper here, I put it in the same location when it comes to my balloon. Alright, so I have my locations here. I'll zoom in so you guys can get a better view. If you look, my A, B, and C, and also D, are right there on the balloon. Alright, so the next thing I'm going to do is continue to read my directions. It says measure carefully in centimeters the distance from galaxy A to each of the other galaxies. Record this information on the data sheet in the column labeled original distance from galaxy A. Alright, and so after I do my measurement, I'm going to come on this second sheet here and I'm going to fill in the table. It says original distance here from galaxy A. Alright, so I'll see what B is from A, C is from A, and D is from A. And then I'll put that in there. You have to make sure you use centimeters. So I'm going to measure that. I'll let you know what I get. All right, from A to B is actually about half a centimeter. So what I'm going to do is I'll redo that because I think those numbers are a little bit close for you to get the gist or idea of what's going on with this. So what I'm going to do is redo this and put them a little bit further apart. All right, I like that a little bit better. Let's see if you guys can see that. All right, so now we've changed up the distances from A, B, C, and D. And then I'll use my marker to indicate that on the balloon. Easy to do, I'll just use the other side of the balloon. All right, so here's where I have them on the balloon. I zoom out so you can get a better view of it. So now we'll measure those in centimeters and see what we get. When I measure the distance from A to B, I get about 4.5 centimeters. 4.5 centimeters. So I'll put on my chart. The original distance from galaxy A to B is 4.5 centimeters. 4.5 centimeters. Okay, and then I'll measure the distance from galaxy A to C. When I measure that distance from the tip of A to the bottom of C, I get almost 6 centimeters. 6 centimeters. So I'm going to put that in my data table. 6 centimeters. All right, next thing I'm going to do is measure the distance. It's important not to let any air escape. Of course, some is going to escape because we have no perfect means of holding it all in. But you want to keep as much in as possible so you have accurate data. Now we're going to measure from the tip of A to D. And I get 7 centimeters when I measure that. All right, now we're going to continue to read, and see what we need to do next. All right. 4 says, blow your balloon up until it is completely inflated. Do not overinflate. Hold the end of the balloon to keep the air from escaping. Again, it didn't say anything about tying the balloon up. It said hold the end so that the air doesn't escape. All right, so I'm going to blow it on up. Now, if I overinflate this, it'll end up blowing up on me. So I don't want it to blow up, but I'll blow it until I think it's good enough. Alright, I think this is plenty good enough on that balloon. Let me zoom out so you can see just how much I've blown the balloon up. Alright, pretty good size. All right, so now what it wants us to do is repeat step 3, which is going to be remeasuring that distance between each of the points to see if anything has happened as that balloon blew up or as that balloon expanded. So I take my ruler again and I'm measuring the centimeters, the distance from point A to point B. All right, now that distance, and I'm gonna put it in the final distance from galaxy A to B was 5.5 centimeters. Now I measure the distance from galaxy A to galaxy C. That distance is 8 centimeters. Now I measure the point from galaxy A to galaxy D. That distance is now 8.5 centimeters. Now, of course, the more I spread them out as I blew them up, the further they would have been apart from each other. All right, so now we're going to do the final distance that they traveled. We need to calculate that. Let me make sure first. You don't want to get too far ahead of yourself. Calculate the distance traveled by galaxies B, C, and D. To calculate the distance, subtract the original distance from A from the final distance of A. All right, so I'm going to do that next. I'll do the subtraction. 4.5 minus 5.5 gives you 1 centimeter. So the distance traveled between the two was 1 centimeter apart. 8 centimeters minus 6 centimeters, that's galaxy A to C, is a 2 centimeter distance. And then galaxy D is a 1.5 because I subtracted that 7 from the 8.5 centimeter difference. All right, so we see as it expanded, there was some travel. Now, questions that I want you to think about and answer for me for class are, what does the expanding balloon represent? Think about this and have your answers on a sheet of paper when you return to school. So number 1 says, what does the expanding balloon represent? Number 2 says, which letter represents the singularity? All right, so you're going to have to look up that word and figure out what it means. And then you'll be able to answer that question. Number 3 says, what do the 4 stickers represent? In this case, I use letters. What do those 4 letters that are marked on this balloon represent? Number 4, what is happening to the universe? All right, what's happening to the universe? And then, what can we compare this to? What can we compare what's happening to the universe to? That wasn't on there. That's just a little bit of deeper understanding. So it's going to be your own thought. What can you compare that to? It can be another subject. It can be something you do in everyday life, something. But compare what's happening to the universe to something in your everyday life or another subject. All right. That's all we're going to do here. This was your Big Bang Lab, your balloon model of the universe. Coach Smith is out.